Lesson 4.4, Adding and Subtracting Rational Expressions. In this lesson, we'll take what we've done so far with simplifying rational expressions and add and subtract. We'll start with like or common denominators. When you add or subtract with a like or common denominator, the first thing you're going to do is simply add the numerators together or combine them. Once you have just one fraction on top and bottom, we'll factor, and very similar to what we did in 4.3. We'll state restrictions in our domain, and then we'll reduce if possible. So this should sound very similar to what we did in our last lesson. Let's take a look at the examples on the right. For example A, what is the sum? We have x over x plus 4 minus 5 over x minus or x plus 4. So they're two rational expressions, and we're going to subtract them. So the sum or difference is like, what is the solution? If we have a common denominator, what we're going to do is just combine the numerators. So it's literally going to be x minus 5 over x plus 4. That's step one. Step two, factor. Well, there really isn't anything to factor in the numerator or denominator because there isn't a common factor or anything that's quadratic. So we don't have to do anything for step two. For 3, state the restrictions on the domain. So remember, in the denominator, we know that the denominator can't equal 0. The value for x then, that would be our restriction, is x can't equal negative 4, because that would make the denominator equal 0. Last but not least, we're asked to reduce. Now remember, if you have factors with variables, the factor on top and bottom have to be identical. We have x plus 5 over x minus 5 over x plus 4. So there isn't a common term on top and bottom that match. Therefore, in this example, that is the final answer. Over on the right, kind of the same idea. Now take a look at the rational expression 2x plus 1 over x squared plus 3x plus 3x minus 8 over x times x plus 3. Well, notice that x times x plus 3 really is x squared plus 3x. It was just written in factored form. What this means is we have like or common denominators. And again, we'll just combine the numerators. And this time it's addition. So 2x plus 1 plus 3x minus 8, that would give us 5x minus 7 over x squared plus 3x. If we factor the denominator, that's supposed to be an x. Sorry, you guys. That should be 3x right there. If we factor the denominator, nothing to hear there. Okay, we're going to get what we had in that original second fraction. So we have 5x minus 7 over x times x plus 3. Now remember the rule for the denominator in our restriction. We know that it can't equal 0. So that means that first x alone can't equal 0. And that parenthesis x couldn't equal negative 3. Those are the restrictions. Now let's see if we can reduce if possible. We have 5x minus 7 in the numerator, plain x and x plus 3 in the denominator. As is, it doesn't look like anything factors here either, so that is our final solution. The best case scenario for adding and subtracting fractions with rational expressions is when you have a like denominator, but that's often not going to be the case. When we do not have like denominators, our goal will be to find them. So what we'll be looking for is called the LCM, or least common multiple. And we'll do a lot of work with kind of converting fractions, and then we'll go back to those 4 steps up above. So for the examples on the right, we have a bunch of different scenarios. Our goal is going to be to find the least common multiple for each set. For letter A, we have the numbers 4 and 7. So no variables, just numbers. The least common multiple would be the smallest number that both 4 and 7 go into evenly. Well, if we take a look, they don't have any common factors. That means the least common multiple is going to be their product of 28. That would be the smallest number that both 4 and 7 go into. And now we're going to introduce variables, and this will make things even more interesting to try and determine. We have an x, a 4x squared, and a parenthesis 2x plus 6. So when you're trying to find your least common multiple, you just want to make sure that all of those different parts are represented. So here's what that means. We have an x and a 4x squared. Technically, the x squared includes that x in the first term, so 4x squared would be the common denominator or the least common multiple of those two individual terms. And then we have that parenthesis, 2x plus 6. So now we could factor a 2 out, and we'd be left with x plus 3. With that coefficient of 2, notice 2 and 4 have a common factor. 2 goes into 4 evenly. So the 2 wouldn't be included in our least common multiple. We're just going to keep it 4x squared. Now, here's where it gets a little tricky. That x plus 3 isn't represented so far in our least common multiple. So that will have to be included. 4x squared times x plus 3 would be the least common multiple of x, 4x squared, and 2x plus 6. I know, this will take a little while to wrap our heads around, so we're just going to try and practice as many of these as we can. In the next example, we have x plus 2 and x plus 3. When it's a parenthesis with x plus 2 and x plus 3, they have to be the exact same to be a least common multiple. When they're different, we include both of them in this process. So notice x plus 2 would be a different term than x plus 3, depending on what x equals. Therefore, we have to add them both in. All right, let's keep going. X plus 2 squared and x squared plus 5x plus 6. So x plus 2 squared means there are two x plus 2 parentheses. X squared plus 5x plus 6 means we're going to factor. Two numbers that multiply to get 6 but add to get 5 would be x plus 2 and x plus 3. So now for our LCM, in that first term, notice we have x plus 2 twice, but in that second term, we only have it once. That means for the LCM, we need to take the parenthesis that occurs the most amount of times in any one set. So we're going to have x plus 2 squared. We also need to include x plus 3 as that least common multiple. That's the biggest amount, or that's the least amount, the smallest that all of those terms could go into evenly. So the more terms we have, the more factoring we need to do, the trickier the least common multiple becomes. And I'm sorry about that. In letter E, we have three separate parts. We have our x cubed minus 9x all together. We have x squared minus 2x minus 15 all together. And x squared minus 5x all together. To figure out the least common multiple, we don't want just any common multiple. We want the smallest amount possible as we create these common denominators. In that first term, x cubed minus 9x. If you factor an x out, we get x squared minus 9. And that would factor into x plus 3 and x minus 3. Again, all one set. X squared minus 2x minus 15 is another set. So what I'm going to do is I'm going to change the color. Whoops. I'm going to first erase the blue and then change the color. So that'll be easier to kind of see maybe these parts that we have in common and the parts that we still need. This is going to factor into x minus 5 and x plus 3. And I already ran out of room. Look at that. Just like that, you guys. That's how easy it is. All right, and that last one I'm going to change the color again just to see kind of what they have in common and what we still need. So for that last one, I have x squared minus 5x. If we factor x out, we'll have x minus 5 left over. All right, so as we look at this, I know, it's just going to be so much fun. As we look at finding the least common multiple, I see this x on the outside right here, and it's just x to the first power. I also see that over here. So there isn't one plain x term that's bigger than the other. That means we can include it just once in our least common multiple. I also see an x plus 3 just once, there's not squared or anything, and another x plus 3, so we'll include that as our least common multiple. I see this x minus 3, but it's not represented anywhere else, so that also needs to be included. Everything needs to be represented the most amount of times that it occurs. Here we have an x minus 5, but only to the first power, and an x minus 5 only to the first power. So that's all we need to create our least common multiple. All right, we're going to stop there. I'm going to let you guys just kind of let this sink in a little bit. So make sure to submit these notes for credit, and that'll be it for today.